so to start with, I'm going to talk about last week's assignment that many people didn't do for whatever reason, and some of the issues that people did have when they did it. So it sounded very simple that, hey, I just have to chunk this up into pieces, but what we failed to think about in a lot of cases is how do those variables move from one location to the other. And so I want to look very quickly at a couple of things and go backwards into chapter 6 because we have to know how this works in order to be able to go forward. So on page 171, we look at the difference between a global variable and a local variable. So if I declare a variable inside of a function, so I just grabbed a program here. So if I have this function called askNumber in this particular case, these values that I create here, so guess, lowest, highest, are only available inside of that function. I can't ask the question in this function, check choice, for example, I can't look at those values directly. Now, I can pass the values from one function to another, and so I can use this return. And so notice here we have guess, lowest, highest, and it passes guess back out of this function into the calling function. So wherever we ask number, it's going to pass one value back out. Those values don't have to always be named the same. So I return a value called guess, but I could have created it inside of a function that asked for, well, I'll just show you here, number. And that askNumber function could have had a value called hide. The value, whatever's inside of that variable, passes back and forth, but not that variable name. And so some people in their code use the same variables throughout their program, and that's fine, but it still doesn't automatically pass it from one to the other. I saw some programs that had errors when I tried to run it about undefined variables because you were trying to reference those variables incorrectly. So there is the option. At the very top of our program, we can create global variables and that are available to everything inside of a program. But we tend to not like to do that. And one of the biggest issues is we don't know where all these modules are going to end up. So I may use a module in different programs. So once I've started writing this code, I may have a display instructions, or I may have a ask for input function that I find very clever. I need to be able to utilize that in a couple of different places. I don't want those variables available to that entire program. So I don't want my social security number available to everything inside of Windows if I'm running a financial program. So those kinds of considerations. So you probably need to go back and reread and look at global and local variables and what the difference is, what the issues are, and why we would ever use those kinds of circumstances. So here's one that I picked out that did work, that had some clever twists. So I wanted to look at it really quickly. So barring my global variable up here to show you where you would land those. So this program started out with, we know we need the random library. They broke the instructions down, which make a lot of sense. Get the instructions out of our main code. So it just literally says, welcome to the Guess My Number game, blah, blah, blah. Here they created a function that generates the random number. But notice, we have a function called random number. It generates a random number, and it passes that number back out of this function to whatever function is called by it. And so we'll trace our way back here in just a second. Then we have a function for ask number. So we ask the user to ask a number to get their input. So we have a couple of variables. We have guess. So we set it to 0, just good practice. So we clear out that value to begin with. Our range is from 1 to 100. Well, guess is not in that range. We allow them to input what number am I thinking of. If it's greater than or less than 1, it prints please choose a number between 1 and 100. So in other words, it's got an error trapping. And then if they generate a value that meets those criteria, it passes that value for guess back. Well, here we have our function they broke into called check choice. And so check choice in this particular case takes two values in. So check choice has two values, guess and number. So it has both this value that's up here and this guess that's right here, and passes them back into this function. And it says, well, if guess is greater than number, nope, try a number that is lower. Otherwise, print a number that is higher. Now, this function then looks at the end result for the user. You are correct, the number was blank. You guessed it in how many attempts. And so it also takes in two numbers, or two values, number and attempt. Our main function, so we set attempt equal to 1, so our first time through you get 1. It first runs our instructions. So when I hit this line in instructions, it cycles all the way up and runs these instructions that are right here. So click, runs that. It then comes back down to our main and says, oh, well, number equals random number, so it runs the random number function. And so that random number function creates a random number and passes a function, a value back called number. And so it passes in its value for number. Guess does the same thing. It runs the function askNumber and passes a value called guess back. And then we create a loop. So as long as guess does not equal our number, so we haven't guessed correctly, it adds 1 to the attempt, and it then runs the check choice and the guess function again. So it'll loop continually until we get to the right number. We then have a function called end. So once we guess the number, it runs a function called end. And end has two values that get passed into it, number and attempt. And that's where we pass it back to this function. And then it prints out the number was blank, and you guessed it in however many attempts. The other kind of clever thing that they did, this particular student, was they also then put the whole program then inside of another loop. So our entire program is really this piece here, this main, we call the main function. Well, they put a loop around that to get this program to allow it to run iteratively. So let me show you what it looks like. So if I run and save it, yeah, that's fine. So it says, guess my number. I'm thinking of a number. What number am I thinking of? I'm going to say 50. And so we could go through this for a while. And there's some strategies. So it tells me, oh, I got 8. The number was 7. You guessed it in 10 tries. And then it lets me ask if I want to play the game again or not. So it's just a clever little adaptation on that. But the key to this, breaking it up into pieces, not that hard. We can define all these functions, but it was keeping track of what variables you're going to use and how you're going to pass them back and forth. So make sure you go back and read that, because like anything, like in math, if you don't get how addition works, it doesn't just go away. We have to keep coming back to it over and over and over again. So Take a look at what your book does on pages 176 through 180, where they break up the tic-tac-toe game, and they go through the same scenario. How do we get this broken up into smaller pieces, and how do we also manage to then pass those variables back and forth? So there were some strange errors because of that. You need to be able to figure out where those variables pass back and forth. So this week, we get even something more exciting. So now, in this particular week, so now we learned how to break a program up into functions. We know about local variables. We know about global variables. Well, in a lot of cases, we want to be able to go out and get information from another source. So we want to be able to create a file. So we've created high and low scores before for a game. One of the problems, though, is how do we know what that high score is in the future? We have no way to store that value. Well, today we're going to get to how do we store a value. And so we're going to be able to reach out, and we're going to be able to reach out and get to a file on our computer. And that's pretty interesting. So, and in fact, we'll look at one really quickly. So what it's storing it as is a text file. And so in this particular case, and it'll make more sense when we start looking at it, but we're storing a lot of information in a text file. So we're going to be able to learn how to read and write to at least a text file and be able to start accessing that. How do we change those files? How do we store complex pieces of data? Well, we can store it internally in that program, but as soon as that program quits or the power goes off, suddenly we're having an issue. Now, the first program they're going to look at is something called the Trivia Challenge game. So I'm going to run it just to see what it looks like. So on the run with a mammal. Let's say you turn state's evidence and need to get on the lam. If you wait too long, what will happen? Well, if I get on the lam, I'm going to ask one. Right, a lamb is just a young sheep. Oh, good. The Godfather will get down with you now. Let's say you have an audience with the Godfather of Soul. How would it be smart to address him? Well, who is the Godfather of Soul? Ooh, Mr. Richard. Let's see what happens. Ooh, that's going to cost you. If you paid the mob in rupees, what business would you most likely be insuring? Oh, what language? So tulips, curry. Oh, your vodka distillery in Russia. Russia uses rupees. Oh, no. It was India. Darn it. So here it gives us your final score and lets us exit the program. So it just goes out, pulls all these trivia questions, but the program itself, so when I look at that program, I don't see any of those questions, do I? If I pull that out, I don't see any of those questions in there. And in fact, where I saw them is here. So what we've done is taken that information that's going to be in those questions that we're going to ask, and we've put them into a text file. And so it looks like, from our remembering that program we just ran, these are the answers. Here's our question. Make it a little bigger. And notice it scrolls to the right for a long way, so each line is separate. So it reads this information, it reads the question, it reads a set of answers, and then this one, if I look, probably corresponds to the answer. So answer 1, and then it gives us a correct answer, and then it passes down to the next one. And so these are all a list of these questions we're going to ask. And we can check this. So we could save it, file, save. We could alter it and see what happens now. So I'm going to run it again. Let's see. And notice here, it's changed that. An episode Brad says to check. So it's apparently pulling that file up. So we want to look at how can we access that file. What kind of things, what kind of power does that give us, this ability to read and write to files? Well, now we can create changes and we can store them. So if we're creating an accounting program, we don't have to worry about the program quitting or the power going off on Friday when we're going to lose power. So we can store information separately. So we're going to learn how to read from text files, and text files have a really good advantage, at least for now. Text files can be found, and we can use them on a Mac computer, we can use them on a Windows computer, we can use them on a Unix computer, you can use them on your Android phone, you can use them on any platform you want to use. Those text files are easy to get to. And if I look on my own computer, you're going to find there's tons and tons of text files. So we're going to look at what some of these pieces do. So the most interesting piece to me is how do we access our file? And so we need to open a file and we need to be able to close a file. So on page 193 begins our journey on how do we access a file. Now, in this particular case, one of the issues with this, and if you've taken the web design class or anything else, you run into the same issue, is I have to point where I'm going to open my file and where this file is created and stored, and I need to know where that is. In this particular case, we're assuming it's in that same folder as our Python file. So I'm going to put a lot of spaces in here so we can see what's going on. So all this does is we're going to open a file. So text file equals open. And then that calls a function called open. And we're going to pass into it the name of the file we're going to open. And then there's a letter. So on page 193, there's a table of these different functions. So we're going to open this file, and all we're going to do in this particular case is read it. So the R tells us we're going to read a file. So there's a couple others. There's W. We're going to write to a file. Now notice, though, if that file already exists, we overwrite it. If it doesn't exist, it's created. So we can create a file, we can write over a file. Notice letter A, we can append a file. So if a file already exists, so if I change this to an A, we would write over at the end of it what's new. We're going to append it, put it at the end of that. Or we'd create a new file. R plus. So in other words, we have a R for read. R plus says we're going to be able to read and write to a text file. W plus says we're going to read and write to a text file. And A plus, we're going to append and read. So in a lot of cases, we need to both pull information and change that information. So we want to be able to open this file and open it for reading, and when we're done, we want to close that file. If we don't close that file, it may hang open And so if we're a very complex program, we may leave a file open for reading or writing and cause an extraneous error. So, well, so we opened it. That's pretty exciting. We didn't get anything out of it. So all this does, this first piece, it says we're going to open and close it. And that's really not going to do a lot. And I'll show you what it does here. So if I run this, so all it does is open and close the file. That's all this set of lines did. Well, that's pretty handy because now we know how to get into the file. So now what kind of things can we do? How can we read the file? And how do we get to the point where we know what information we want to get out of it? So we're going to add then, we want to read characters. And so if I notice that text file that I had open, so I'm going to open it back up here again. So all that text file looks like is line 1, line 2, line 3. So nothing very exciting, but we're going to read that file and pull information out of it. So the next one we're going to do, so we're going to read characters from the file. So we have to open it, so we text file equals open. We're going to read it, same file, so this one down here. And we're going to pull individual characters in. So we're going to print text file.read. So we're reading that file, and we're going to pull the first character. Huh. Okay. And then we're going to read character 5. Okay. So what does read 1 do? So if I read one character, let's see what happens. So over here, this is what happened. Reading characters from a file. We read 1, and it read the L. But notice what happens next. I then said I want to read 5. So it pulled 5 characters. But notice what it pulled out. Did it pull LINE space, which is what I would think it would do? Notice it already had put a marker in there, and it read the next 5 characters. Huh. So it had marked L as being already pulled out, and it brought the next 5 characters out. Then again, our good programming practice, we close. So one of the things that that close does is reset that counter so we can go back in and read it again. So a couple of other things we can do. We can read that entire file at once. So same structure. We open our file. We're going to read it. We assign a variable called whole thing. We assign it to text file.read. And notice we don't pass in any values. So when we don't pass any values, it says we're going to read the entire file. We then get our entire file printed out. So reading the entire file at once, line 1, line 2, line 3. We get all of that out from that one line, read the entire file. So depending on what we're doing, we may want to do that. To get an individual character, we may want to get the entire thing. We may want to figure out something else. So let's look at this again. So up here we read 1 and then we read 5 characters. So we marked it, we started at the beginning. Well, let's see what happens here. So we're going to read characters from a line. And so just to make this a little easier, let's get rid of some of this junk we're not doing. So we can read the entire file at once. Save it as a new name. So now I'm going to run this. And so the first thing I'm going to get is I'm going to get an L, an I, and E. So we know how to read characters out of a line. So how do we then get one line at a time? So we can force it to look at it one line at a time. So let's look down one more line. So here we opened up our file again. We're going to read it. Well, here we have the ability, we're going to print a read line, a read line, and a read line. And so each time it goes through, let me save this one. So each time it reads one line. So line 1, this is line 2, this is line 3. And so it did that with those. So the problem is we need to know how many lines there are, and that kind of seems silly to copy that over and over again. So maybe there's an easier way to read our lines into some kind of a list. So here we can read our entire file into one list. And we know that Python works with lists pretty easily. So we start with the idea we're going to open our file again. We're going to create lines equal text.file read lines. And so we pass the entire thing in there, and then we're going to print lines. We're then going to print the length of lines, and then we're going to create a loop. So let's see what happens. So I'm going to, for now, because I don't want this to print or show. So all I'm going to do is this statement here. So let's see what happens. Run module, yes. Okay. So we read the entire file into a list, and we printed that list. And so it printed, and notice what it did. It put it into this list format, line 1, line 2, line 3. And then we looked at the length of the line, and it said, oh, it's 3 pieces in there. Well, that's good. And then we ran this loop, and we printed each individual line. So we can take that all in at one time, and that's a pretty slick way to get details. So I'm going to delete this. Take out my. So I'm now going to look at something slightly different. Yes, okay. And now I've created a way I can loop through that file line by line. So we can read the entire thing in, and if it's a small program, that may make sense. The reality is if that file is very large, so our text program may have thousands of different entries, maybe we need to loop through it and not pull it all into one list to start with. So here, once again, we open that file, and we create a loop. So for line in text file, so this will loop as many times as we have length in there. So print line, and then we close the file at the end of our loop. Well, if I want to change this, this is now line 4, line 5. So I'm going to save that, file, save, and now we're going to rerun this program again and see if it did catch all those. So run module, and notice now I changed that text file, and it went through and caught all those extra pieces in there. So it's going out and reading that file just like we thought it would. And so reading it then gives us some interesting tools. That program, that trivia challenge, all it did was read the file. So we can read all the lines at once, we can read them one by one, and so there's some advantages to each particular method, and it depends on the size of your file, what you're going to do with it. It's very handy if I read that entire file in and I have it stored as a list, but if I have 1,000,000 items in that list, that's not very handy. Now, we're not going to create a program that's got 1,000,000 items in it yet. But we are going to look at how do we write to a file. So if I wanted to change this, so I wanted to write to a file versus read to a file. So I can very quickly, let's see here what I want to do. Let's do this. I can So once again, it looks very similar. I'm going to use the open command. And that open, notice when I use that in here, it gives me some information. And so I know that I need to create a file. And so I'm going to call it write it to. Now, because I'm going to write to it, I have to have some kind of a method that's going to allow me to write. And so in this case, I'm going to use W. So I'm going to write to a file. So now we know that that's what we're going to do. We can use, so now we created text. And we can add the dot notation dot write. And it's a function now, so we're going to pass that in. And so we can put in information that way. So, and notice we can do, so we can write a couple of lines. So I'm going to cheat, because I like to copy and paste. So this is line 2, and maybe we'll do a third line. Oh, apparently my copy didn't copy, paste. All right, so we're going to create 3 lines. So we've written those out. So that write command allows us to write into the file. So one thing about it, you need that new line character. If we don't, it just appends them into one long line. And so next we need to close that file because we're done with it. We always want to close it as soon as possible so we don't accidentally leave it open. So we're going to call it text file dot close. And we don't pass anything into that close, but it is a function. So let's see if this works. So I'm going to take this out, delete it. And I'm going to say run module, okay, save. Huh. And it seems to have run. It didn't do anything we can see yet. So I'm going to go back up to my folder for chapter 7, and oh, look. There's a new file called write it to. Now, notice that I made an issue or an error with it. So over here, all those are text files, aren't they? Well, it very literally tells me what I need to do. I didn't write it as a .txt. So let's run this again. Let's save it and run. All right, so it ran, nothing popped up on the screen, and let's go back into my file folder and see if it created, aha. So it created something called write it to. We can open that in a text editor, and look, it put this is line 1, this is line 2, this is line 3. So just to show you, if we don't use the new line character, what happens. And remember, Python and any of these programming languages do exactly what you tell it to. So run module, okay. So I want to show you a couple of things when we do this. So notice I said it would write over the top of it if we just used the write command. So it took that and it wrote over the top of our existing file. This is line 1, this is line 2, this is line 3. And notice it put it all on one line because we didn't tell it to put a new line character and pass it in there. So I'm going to delete that. Let's see if we can make it reappear. So I'm going to delete the whole file. I'm going to run this program again. And let's see if it appeared. And notice there it appeared again. It created a... Now, can I do something even really screwy? Well, I can. So, because our computer in some cases does exactly what I want to tell it, notice what happens if I do this. So I'm going to run it, and I told it to save it as a .doc file. Now, it's not really a doc file, but notice what... Oops, back here. Notice now, because Windows just looks at that extension to see what that file is, Windows thinks it's a Word document. So there are some security issues doing this, but I just wanted to demonstrate and show you that. So you need to make sure that you save it as a .txt. More interestingly, what I think is you can write a program that writes its own code, because I can actually create a py file. So look at this, run module. And so if I had that statement correct, notice it just created write it to as a Python file. So I could create code that creates more code. So for everything we're going to do for now, you just want to do it as a txt file. It's universal. We can see it with about anything. So we're going to be able to read and write to these files pretty easily. So on the bottom of page 198, so we looked at a write character. Well, there's also a write line. We have some other things that we can do. So on page 199 at the bottom, there is a list of file object methods, and it is not inclusive. So there are other ones that we can do. So if I want to write a single piece, I can use write. If I want to write an entire list or a set of strings, I can do that also. And so instead of writing 3 of these, I could have very quickly said, you know, I'm going to create, and let's just call it list for simple sake. And list equals and so we're going to create a list of all these items. So just to make my life easy, and so we could put in an entire list of these. And we looked at how easy it is for us to work with these lists. So, hit the right one. So we created a list, and rather than pass in these one at a time, let's get rid of 2 of them. We can modify that instead of a right, we can call it a right line. And when we do that, we can say, well, interesting. So we can write in then, instead of having to put this value in as a, we call it list. Notice now we're passing in a variable into that right line. So if I didn't spell anything wrong, yes. Nope, I apparently did spell something wrong. So probably something odd in my spelling. But we can actually then, oh, duh. Okay, so now it's ran. We created a file called write_it2. I can go look at that file. So there's my write_it2. We can see when it was just edited. And this is my list line 3. So that gives us a way to create that very quickly. Now, notice I opened this as a W, so I'm writing to it. If I flip a couple pages back, I had some other options. So there are a couple of different options I have. So if I go back to table 7.1 on page 193, I have a W for write. But maybe what I really want to do is an A for append. And so let's see what happens when I put an A for append in and I run this same program. Yes, I want to save it. And I want to go look then at my, so I just modified this again, and notice I can tell from the time. So now I'm going to open it up and look at it. And notice it appended, it put it at the end, added in another set of lines. Huh. So depending on which way we want to do and what we want to look at, we can write this in a couple of different ways. So charts in here are very important. I would highlight them. So we can even do some really, really interesting things. So we're going to look at another program here. It's already on in the course documents if you want to look at it. We're going to look at a program called Pickle It. And so we're going to edit it in idle, so we have an idle window up. And so notice that Pickle does something interesting here. I import a library. I'm importing libraries called Pickle and Shelve. Do those sound like they come with Python? The random one's pretty common, but how often do we need to pickle something? And so we're actually going to import a library that we've created. Interesting. So let's take a look at some of the items in here. So I'm going to run it and show you what it looks like first. So pickling lists, unpickling lists, shelving lists. So it puts data in and out is all it's really setting to do. So we're going to take some files and we're going to see what they do. So the pickle module, we can store data and then we can store it in a shelf. So take a look here. We have variety equals sweet, hot, and dill. Shape equals whole, spear, and chip. Brand equals Clausen, Heinz, and Vlasic. So all we're doing is looking at the different types of pickles we could have. So variety, shape, and brand. We're going to open up a file, and notice this file isn't a .txt file. It's called a DAT file or a data file. And notice we have a different extension out here, what we can do with it. So we have a WB. All right, so let's look on page 201. there is a list of binary file access modules. So RB says we can read from a binary file. We can WB or write to a binary file. So it looks the same except we put this B in front of it to tell us that it's a binary file. And so if I go back into here, notice here I've got a DAT file. When I ran this program the first time, it created that file. So here's where we create that file because we're writing a file, and notice it says if it doesn't exist, the first time it runs, it creates it. So we ran this file the first time. It created this file, pickles1.dat. So we then have, because we imported this function pickle, we have something called dump. So we have pickle.dump and variety. So what does the F stand for? So what do we use that F for? So notice on page 203, there's a table 7.4 that talks about the pickle functions. In other words, how do we pickle or create data to store it together? So notice there it says dump object, comma, file, and then it's got this binary thing. So if bin is false, object is written less efficient, but more human readable. The default value is false. So we can actually look at this file if we wanted to. So we can open it with, I want to open it with Notepad just so we can see it. And notice that we can kind of see what's in there. So it kind of looks like sweet, hot, dill, but it's nothing that we can read and utilize ourselves. But it packs it together in a binary format and makes it as easier for the computer to utilize it. So what this command did in this file was it dumped the contents of variety, dumped the contents of shape, and dumped the contents of brand into this pickles1 file. Well, now we want to go back in and we want to read that data back out. So we want to unpickle it. So in other words, we compressed it. Now we're going to uncompress it if you want to think of it in those terms. So here, once again, we're going to open that file, pickles.dat. And if I go back to my table on page 7.3, we're going to do an RB. Well, that's a read a binary file. And we're going to assign variety equals pickle.load, shape equals pickle.load, and brand equals pickle.load. So in other words, it's going to break it into those pieces again, and we're going to print them out. So that's what this portion did. It pickled it into one big file, then it read the file and printed out 3 different pieces of it. Because that pickling allows me to store it, and it does put a character or some way of spacing in there so I can go back in and get 3 different pieces of it. So I close my file again. Well, we're going to do something called shelving. So if I'm going to shelve them, shelving allows me to not just read this list and retrieve it. Shelving gives me the one other advantage. So I create one big file of all my data, and it gives me random access to my data. And so depending on what I'm going to use that data for, you can see in a small list like this, I could go in and grab that whole list very easily. But I can't with a very large list. Again, imagine if I had 1 million items, or I were a pickle store and I had 1,000 different varieties of pickles. shelving allows me to read and write that data into this list that's stored in one big binary file individually, and so, or in random access. So let's look here. So we assign a value for, here we used F for file or whatever we called it. Here we're going to use S, and we say shelf.open. And notice we took that file we created earlier, and we're going to change the number one number. So we create a separate one. So if I look in my folder, wrong one. Notice the first time it ran, it created a pickles2.dat. Well, when it created a couple other files we're going to look at here in just a second. So we created one called pickles2.dat. That's the file we explicitly named. So now look what we've done. We create S variety equals sweet, hot, and dill. Okay. S shape equals whole, spear, and chip. So in other words, we're putting an association with them so it will do something. So you're pairing up, in other words, a brand with a type or a key, if you want to think about it that way. You're making some kind of an association between the two. So it's pairing everything in this variety with these items. And it doesn't have to be just 3. There could be more. And so that passes all that items into this file. And then we have something called sync. And you probably are used to the idea of sync. Well, we don't always write files immediately in our program. Sync forces it to go out and write that file. Well, here's where it gets interesting then. So we can retrieve those lists then So we're going to print that list from our shelved file. So dynamically, we're going out and getting those things that are in there. So we're going to print brand, and notice here we're going to print S sub, if you want to think about it, brand. So those things that are with that index key. So the same way we could do that with lists, we could create a key based on a number or a letter. We could do the same thing here. So we're taking those that are with shape and those are with variety, and then we close our files again. So this particular piece, I'm going to get rid of the first half of this. So I'm going to run, I'll just, whatever, get rid of it. Okay, so it put that list over, and now it retrieved it by brand. So it said, well, all those items that are in brand are Clausen, all those that are shape, whole, spear, and chip. So it allows me to go in and get these items on the fly, back out of my list. But what I want to also point out is it creates a couple of other files. So if you use them, notice a couple of files that it created. So I'm going to get rid of all the DAT files and all the ones that look weird for now, and see what happens when we run this program. So all the pickle files are gone. I'm going to run this. Okay, so it ran. And now look at it's got 3 different files it created. Well, I told it to create 1, didn't I? Why did it create 3 files? Well, when we start working with those DAT, those binary files, we're starting to get a little more powerful. And underneath the skin again, Python's doing a lot of things that we don't have to deal with. And so one of the things it's doing, so I'm going to open this with my text editor. So notice what it did here. It created some kind of a backup. And wow, I don't know what these mean, but we'll find out and think about them here in a second. So it created a backup file of some sort. We can open this with, even though it's not the correct application, we can look and see what it looks like internally. So we're going to open it with Notepad. Notice it's that same one. It's got some odd characters. And then we have a directory. And notice that directory and that backup are the same thing. Well, what this really is our kind of like a phone book of how to find that information that we stored in that big file. And we can look at this. And so if I looked at what's in our file we're creating, back to, so if I look in here, variety is equal to some number of characters. Well, what that directory does is it stores them in blocks. And so it's saying in block 1, which starts at 0, called variety, and it gives us some information about it. It's length, in other words. It then says we have another block at 512, and we have one at 1024. And those are the default block sizes that it uses. So we're actually creating some blank spaces in there we're not utilizing, but it's still more compressed than if we had just stored it as a text file. And so that backup directory, if we ever somehow delete that directory or it gets damaged, it just creates a second index or a second way to get that data back out. So don't panic when you see all those, but when we turn in assignments, for example, if you're going to turn in one or you're going to create one, you need to have all those files in one spot together. We haven't yet showed you how to store them off in other locations. So this chapter, you really, really, really have to work through. There is no other way other than working through this chapter to get through this material. This is probably the most complicated, but also the most exciting piece, because now you're getting to go out and you're writing things out. And so I would start with the beginning and look at how do I just write a text file. Play around with it. Try writing text files. And then we'll get to the point of starting to write these binary files, and we'll start looking at what they look like. So because it's interesting, and I think it's an interesting game, and we talk a lot about binary, and we've introduced you to that idea, to practice your binary, there's a fun game. So on almost any device, you can find a game called 2048. And so I usually don't encourage you to go find a very addictive game, but because this game works with the idea of twos, and we looked at this game I'm going to say go find. So in this particular case, it's much easier on a touchscreen device, but what you're really doing is you're combining, and notice your goal is to hit now it's like again much easier on a touchscreen device. Go, but your goal is to join these together and eventually get to 2048 or higher. And so there's some interesting rules, but what it does is it reiterates that idea in your head about the powers of 2 and how often we use them around here. And this is one of the most addictive games I've ran into. All right, so this week's assignment we'll take a look at on Thursday. We'll finish up the rest of this chapter. Make sure you go through and you've submitted your code and you looked at what your other fellow students have done. Help them debug their code. So if you see, hey, I could fix this here, or this is why your program doesn't work, help them out. These are getting to the little more complicated. The most common thing we're going to see is passing variables. It's not uncommon for commercial software to have issues with passing variables, quite honestly. So go out and play this game. You'll find it addictive. It teaches you again about those powers of 2. We use twos in every one of our digital programs, our digital coding. So I thought this is kind of an interesting game. You may already have it on your computer. It's one of the interestingly most popular right now. And quite frankly, it's far more entertaining than Flappy Bird ever was. So, all right. We'll see you again here on Thursday.